Hi, in this tutorial I am going to show you how to create the Darpa Suboff Submarine Geometry in Prefoam. First of all, you need to find the PDF file that describes what the geometry looks like. So if you do a Google search, Darpa Suboff Geometry, you will find this PDF file called Geometric Characteristics of Darpa. If you open the PDF file, you will see descriptions and basically equations for parts of the submarine. So on this page, for example, you will see the bare hull, what it looks like, and the equations describe sections of this geometry. So you need to input this in some form and create points, and from these points you need to create splines, so interpolated curves. So if you go to this icon and then to the menu, you will find a tool called Points from Equations. If you hit on that, you will see on this left part a widget. So you will need to input the equations in this section. In this edit field, you can enlarge it, you can edit it, and then hit OK. And as for inputs, you can either input x, y, z variable. You can also input two, like x and y, and the output will be adjusted to the third variable coordinate. So you can also add parameters. You can add rows like r equals 2, for example, and then you can write something like r times 2 or x. In this case, if I hit on preview and zoom in, you will see the points basically. Like this. You can also do unit conversions. The hull geometry is defined in feet, so you can input feet and output millimeters. You can also use the active grid. You don't need to use the grid that is predefined in the world XYZ coordinates. You can also create custom grids and then hit this button, and then your variables will be created in this active grid. So if you have a curve or points, you can hit this checkbox and it will create automatically the curve. Now let's switch back to millimeters, otherwise it will get confusing. So you can also save the equation to the tree, to the object tree, then it will appear up here. I created basically all the geometries up front. And what you can also do is hit on this question mark and you will see a description of what a JSON file will look like if you want to create the geometry with the help of artificial intelligence, for example Claude. I used Claude to generate these. What you can do is copy this description, paste it to the AI, and then take a screenshot of this page and then send it to the AI, and it will create the like these entries. And then what you can do is open the clipboard. So you copy from the AI, you paste in this field, hit OK, and it will load everything. So that is how I did that, and you need to be careful to check the equations, because this is a old file. The AI will probably not read everything correctly, so you need to watch out. This for example, Claude read that as a 9, so you need to be careful. Now if I hit escape, that will be removed. So the first thing to create is the bow equation. So if I double click on this, you will basically see everything. If I enlarge this, this is what the equation looks like. It's exactly in this format, generated by Claude, and the parameter Rmax is exactly 5-6 feet, and then you need to apply the range and convert from feet to millimeters, and then once you create this part, you can hit apply and save equation to tree, and then hit escape. I will do that quickly for the others. Now you see in the preview the parallel section, hit key E, and then after body. It is exactly this equation on this page. It is really long, so you need to be careful to check if every entry is correctly added. So hit E, and then after body cap is this small section over here. It is on this page the last equation. So hit E, and what we have here is exactly what is shown also in this diagram. So we need to close the hull. So I will box select this and hit on this icon to create a surface. I will hide the curves and hide the grid so the face is then visible. Now I will use the revolve tool. So click on the shape you want to revolve and click on this icon that will tell which targets I want to revolve. Then next, go to edges, select edge, and then click on this. This is the axis of rotation, and then hit on this icon, and what you will get is you will get this arrow. You can hit A for angle, and then hit 360 for full revolution, and then hit E for execute. Now if I hide the original face, you will see the hull, and it might look edgy if you look at this curve, and this is because of the rendering. Okay, if you hit this hull and create on this color options, you can change the tessellation. It is basically how you see the shape. The lower the value, the more curved it will look, like this. You need to be careful because it can get slow if you take very small value. So for now, this is the shape we have. So let me hit quick save. So the next thing we need to create is the fair water, also called the sail. So this is basically this section on this upper part. So the sail forebody has this equation, and then sail parallel, sail afterbody, and then you have sail cap. This is a ellipsoid on top, and if you create these, let me deactivate this. So sail forebody, if I hit on that, you will see a green preview here. I will hit E, sail parallel, hit E. So this is basically I think sail afterward and sail cap. In the sail cap you need to be careful because the Z1 equation is from the 3 parts here, so you need to split the equation in 3 parts. So let me show you. So sail cap 1, 2, 3. This is basically one equation, but the Z definition is different for all these. So if I open this, as the Z1 definition so I show you the wrong equation. So this part, so you basically see how Z1 is defined, and it is different for all. So, and you will input x, y, not only x coordinate, and Z will be your output. Like this, and then hit apply, sail cap 2, hit apply, sail cap 3. So once we have these, so basically on the bottom section you have 3 edges, and then on the top section you have 3 faces. So I will enable vertex selection and then auto connect vertices tool. Okay, I will close basically this and merge these into a buyer. Basically I can box select, enable edge selection, box select, and then hit on this stitcher. So afterwards I can create in a closed via the face. So what is missing is the same procedure. Select the vertices and connect these two, and then let me show you another tool. This tool is called fill hold surface. What you can do is you can select the edges and then hit this, and then we want positional, and if I hit this you will get your face. So same thing here, and it will close. So what is now missing is the connection. So I will call the loft tool, and then I will hit this face, and then this face, and then if I hit OK, you will see that the geometry looks okay now. Now we have here the closed faces. When I stitch these together, I will get the swoon shell, and this is basically a closed shell. So I can hit this icon solidify, and it will create a solid shape. If I take the loft and then hit on this icon for fuse operation, it will fuse solids. So if I hit E, what I got is a fused shape. And from time to time, this fuse operation can take a while if the shape is complex. So obviously we need to mirror the shape now. So hit the mirror icon, select your shape, hit target, switch over to face selection, select the face, and use it as a mirror tool. So hit E for execute and get out, hitting escape. So we can select both, hit the fuse operation, hit this again, and then we will hit apply again. And when it's done, hit E, and you have your shape. So we need to merge this now with the hull. So fuse operation again. You can select from the object tree also. Hit this. You can also hit these both. Once done, hit this, hide the surface. So we have the bare hull and the sail. What is missing is the stern appendages, and this looks basically like that. You have three options. We will take the baseline option, and the equation is down on page 14. So you will need to insert this value for h, and then we will create two sections for y0 and y at the maximum radius of the bare hull. That is 0.833 feet. So this variable we need to change to x, so you need to rearrange this and then insert your y values, and then you will have an equation that will be dependent of x only with the range of x, and you will output the z value. So it will look like this. This is basically your equation over here, and these are then your variables, and then the range is like this. So after this, hit apply, and stand top will look like this. This is basically the same equation, only the y value is different. So hit execute, and then let me deactivate this. We will need to move this, so hit on this and then hit this icon, and you can drag it around. So we need to, it's like this feet, and I think the conversion rate from feet to millimeters is like 300 for something. So with this here, hit execute, and then the same game, like select the vertices, auto connect, select both, hit E, select the edges, stitch, select these and stitch, and then we will use the loft operation. So select both, create solid, make it flat, we need to mirror this. Oops. Hit E, select both solids, hit the merge, there might be small gaps somehow. Okay, now what do we have here is this turn appendage. So click on this, hit this pattern icon, and then from the axis we will activate the origin. So select the Bond's turn appendage, hit on this icon, and then we need a reference axis. So I will select this X axis and then hit this, and the axis will be highlighted. The pattern is circular, we want 4, and the total spacing is like 360 degrees, so it will create 4 of these in 360 degrees. So hit escape, hide the axis, and then we can select these and then hit apply, and then it should merge all of these into one geometry. Hit E, and this is then the geometry. You can now use this to do a CFD simulation. So thanks for watching, and see you in another tutorial.